So you can factor with algebra tiles. The thing is, what you have to do is you have to take what you've got. So, oh, I need some minus x ones. All right, 1 second. So what you need to do if you're going to factor using algebra tiles is you need to gather the tiles you have. So we need 1x squared, negative 5x's, and 6 1's. And our job is to try to figure out how we could put this together in a rectangle. So this isn't necessarily fast, because you could be fiddling around with this for a long time. Eventually, you might realize that, oh, if I put 3 of them here and 2 of them underneath, and then my 6 1's in this spot here, that it makes a perfect rectangle. Of course, this might be 30 minutes after you started doing this. How did I do this? I cheated because I used the fact that we already know how to factor. What's this going to be? X and x. How am I going to get 6? 3 and 2, and they would both have to be negative. So I cheated a little bit because I already knew the answer, so I knew how to build my rectangle. Why is this the rectangle that goes with the algebra tiles? Because we think about algebra tiles as area, and we think about factoring as changing something into length times width. This length here is an x, and then minus 1, minus 1, minus 1, minus 3. And this length here is an x, and then minus 1, minus 1, minus 2. And so we could take what we have, I'll write it like this, x minus 2, and make our rectangle. Thinking about the chart method, does it make sense that these would be positive ones? Because we have a minus 2 down here times a minus 3 up there, making those 6 positive ones. But again, I think directly factoring it is probably easier. We could do our second one with algebra tiles as well. Now we have 2x squareds, 11 of our x's, and 5 of our 1's. How are we going to do this? I'll put my 5 1's like that, and I can put an x here. Good thing I didn't pick a bigger number. This would take forever. Da, 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 da. Does it make a rectangle? Yes. Do I have 11 x's? Yes. Do I have 5 1's? Yes. What is my length? X, x1. This will be 2x plus 1. X plus 1, 2, 3, 4, 5. X plus 5. Of course, it might take you a long time to actually make the rectangle. Other things that are problematic with this method is if you get something that's not factorable. That means you can't build a rectangle. But you might try for an hour to build a rectangle and just get frustrated and mad at yourself that you can't build a rectangle. And then when someone tells you, oh yeah, that one you can't build a rectangle, then you get really mad at them because I just spent an hour trying to build a rectangle, and now you tell me you can't build a rectangle. So it's much better. Should I make one that you can't build a rectangle?
No.
Well, and we're not going to spend an hour doing this, but let's say you're asked to factor this, x squared plus 2x plus 7, right? If we use the idea that we've been doing so far, you would know that this would have to be x and x, and the only way we can get 7 is with a 7 and a 1. Does that ever make 2?
No.
No. So you know right away that it's not possible. But if you had one of these, 2 of these, and 7 ones, you might try to start rearranging things, and you might take a long time to realize that, oh, it doesn't actually work. Can you imagine it, having 7 little ones and trying to make a rectangle? It's going to be a problem because you can't make it other than a 1 by 7. Otherwise, it's not going to work out. So maybe it wouldn't take too long to find out we couldn't build a rectangle with this. But sometimes that can be frustrating. So the algebra tiles is nice to see the connection between area and length times width. That's valuable. But as a technique to actually factoring, it's not very efficient. Okay? And so it's not something that we're going to use directly. We'll probably go with the technique that we've learned already, just thinking about how it works.